What's up everyone? In this video we're going to be going over some complex circle diagrams and finding a bunch of missing pieces. So here's a vocabulary refresher. We have our tangent line touches a circle one time at the point of tangency, and we create a 90-degree angle with the radius or diameter. So even if we have a circle where we know that this line right here is tangent, even if there's no radius drawn in, we know that if we did draw a radius that there would be a 90-degree angle there. We also have a secant line, and a secant line is passing through your circle at two different points. And then we have an inscribed angle, where an inscribed angle has its vertex as a point on the circle. So for an inscribed angle, your point or your vertex has to be any point around the circle, and then we have chords that create like the sides of the angle. And then we have that a central angle, their vertex is at the center of our circle. All right, now these are all of the formulas that we've learned thus far to find some segments. So if chords are intersecting, we know that we can take the parts and multiply them together, right? So A times B equals C times D. And then for the secants, we have the formula we, where we have whole times external equals whole times external. Now, if you remember we, you'll know when you can apply it because you need a whole segment and an external piece. Whereas if you have something like chords, like in this example here, you don't have any external pieces, right? And if you have a tangent line that's drawn, your whole entire segment is external, right? So we, whole external, you can only use it when you have secants. And then if you have a secant line and a tangent line in the same diagram, we have the formula we equals tan squared. And again, this whole times external, you know it has to be for the secant because again, a tangent doesn't have, the whole piece and the external piece are the same because the tangent does not go inside of the circle. Now, for our angle formulas that we've learned throughout this whole unit, if you have intersecting lines with an angle inside of the circle versus outside of the circle, there are different formulas. So both of them, our angle is equal to 1/2, and then the big arc and the small arc are involved for both of them. However, if your angle is inside of the circle, whatever angle you're looking for, so x equals 1/2 of big plus small, and again, these are talking about the arcs, big arc and small arc. And then if your angle is outside of your diagram or outside of the circle, it's going to be 1/2 of big minus small. And again, these are talking about the arcs that we are intersecting. And then this one's a little bit further back, but an inscribed angle is half the measure of the arc that it intercepts. So if we know that arc BC is 80, we know that this inscribed angle is going to be 40 degrees. And we also know that if there was a central angle in here, and we knew that that central angle was 80 degrees, it follows the same exact thing. So it's half of the arc or half of the central angle. Okay, now we're going to get into an example that utilizes a lot of different theorems. Now, these are the diagrams, the most complex circle diagrams that you'll see, but it's important to make sure you annotate the question, figure out the segments that you have, label your diagram, and then get to work. So we have chords AB and CD. So chords AB and CD are intersecting at point E in circle O. Secants FDA and tangent FB are drawn to circle O from external point F. So right now, as I am reading, I'm also tracking this in my picture. So secant line, FDA is right here. Then we have tangent line, FB over here. So our secant we'll keep in red, our tangent line we'll make blue. And then it's saying, like, we can see that they're both meeting at this external point F here. And then it says chord AC is also drawn. Now it says the measure of arc DA is 56. So 56 is going to go right here. The measure of arc DB is 123. And the ratio of the measure of arc AC to CB is 3:1. So whenever we see these ratios, we put X's in. So AC goes with this 3 here. So we're going to have 3x in for AC. and then CB goes with this 1. So 1x right here. We're not even done yet. FA is equal to 8. So I'm going to go ahead and put brackets so we can really see that this whole entire thing is equal to 8. We have that DA, which is just this small portion right here, is equal to 2. We have AE, which is here, is equal to 3. We have EB, which is here, is equal to 6. And last but not least, we have that DE is equal to 9. Now, there is a lot going on in this question. All right, so the first thing that I'm going to do, because I can see that we can solve for it right away, I'm going to try to solve for x just so that we can get rid of any variables right now, because this question is going to be able to ask for a lot of other stuff. So whenever we're looking to solve for something, we got to think, okay, what's an equation that we can make to help us solve for it? Now, I'm noticing that we have arc measures or things to represent the arcs all around the entire circle. And we already know that if we fully go around that circle, if we fully make a circle, we get 360 degrees. So when we're solving for x, we can add up all the arcs. So 123 plus 56 plus 3x plus 1x. And if we set that equal to 360, now we have an equation that we can work with to help us get a value for x, and then we can substitute it and get a value for the arcs. So when we do that, when we combine our like terms here, we get 179 plus 4x equals 360. And then when we subtract that 179 on both sides, we get that 4x equals 181. And then when we divide by 4 on both sides, we get that x is equal to 45.25. So now not only do I know what x represents, but now we can also go ahead and substitute them back into our diagram to figure out what arc AC and arc CB actually measure. So we already know that arc BC is going to measure 45.25, and we know that arc AC is going to measure, if we do 45.25 times 3, we get 135.75, right? So this is something that we can take with us through the rest of the question. So now let's see what else this question can ask us. So first it says to determine the value or the measure of angle CEB. So the first thing that you want to do is identify where angle CEB is. So angle CEB is this angle right here, this one. Now, what I notice is that we're solving for an angle that is inside of our circle, so I know that we can use this formula that says, hey, our angle is going to be equal to 1/2 of big, and since the angle's inside, we're doing big plus small. If our angle was outside of the circle, it would be 1/2 of the big arc minus the small arc. But first thing, or the next thing we want to do is highlight the other parts of the chords, right? So we can actually see the arcs that are involved. So right now I can see that arc BC is definitely involved in this, and we can see that arc DA is definitely involved in this. Now, let's just go ahead and substitute. Now, x represents this value of that angle, so we don't have that yet. X equals 1/2. Our big arc is that 56 degrees here for DA, and then our small arc is 45.25. Now, once you're at this point, be careful when you're plugging it into your calculator, but once you have your variable by itself, you can go ahead and do that. So we do 56 plus 45.25, and then that's going to be divided by 2. And when we do that, we get x equals 50.625. Now that means that the measure of angle CEB equals 50.625 degrees. All right, now the next thing that we can do is we can also go ahead and solve for the measure of angle F. So let's go ahead and do this in a different color. Let's choose an orangey color. So angle F is over here. Now the first thing I'm noticing is that this angle is outside of my diagram. It's outside of the circle. So now instead of doing 1/2 of big plus small, it's going to be 1/2 of big minus small. Now we have to figure out what arcs we're actually talking about. So to do this, it's really, really helpful to highlight all of the pieces of your angle. So angle F is comprised of this segment that we're highlighting over here and this segment that we're highlighting over here. And we want to mark all of the points that are angles touching the circle. So right here, and right here, right? So the first arc that we're talking about is going to connect these 2 points. That's arc, the 123 degree angle measure. And then the other arc is going to be over here on this side, connecting the other 2 points. Now this entire arc is going to be 135.75 plus 45.25. So let's go ahead and figure that out now. So we do 135.75 plus 45.25, and we get 181 degrees, and that's going to be for our big arc, 181, and then our small arc is 123. That's this piece right here. So these can get complicated because sometimes it's tricky to figure out the arcs we're talking about, but use your highlighter to help you. Now we don't have the measure of this angle here, right? So we're going to keep that as x. So 1/2 of 181 minus 123. So we do 181 minus 123. We divide it by 2, and then we get that x is equal to 29. So again, we have angle F equals 29 degrees. Now last but not least for this slide, we have to find the measure of angle DAC. Now DAC, we can't really see it right now, but DAC is this angle that we are highlighting in pink right here. And this here angle DAC is an inscribed angle. And we know that inscribed angles are half of their arc measure, right? So again, to figure out the arcs we're talking about, we mark the points on the circle. So right now, the arc we need is this one that I am highlighting in pink, right? So to find out how much that entire arc is, we have to do 123 plus 45.25. And that entire arc is, so we already know our angle is 1/2 of the arc. And that arc now, when we added those two numbers up, is 168.25. And when we divide that number by 2, we get that x equals 84.125 degrees. Okay? All right. Now let's clear our slide off to do the next 2 questions. So next question says determine the length of tangent FB. So FB is this blue segment that we have over here. That's our tangent. And we noticed too, right, in this question we annotated that we had a secant and a tangent. So whenever we have a secant and a tangent, we know that we can use that formula that says, hey, we equals tan squared, right? Now this we, that WE, is talking about the whole and external of the secant. So the whole secant measures 8. The external portion of the secant is over here. Oh, sorry. The external portion of the secant is over here, right? So we know that the whole secant is 8, and we have that this piece is already 2, which means that the external portion has to be 6. So the whole secant is 8, the external portion is 6 equals, and our tangent, that's what we're looking for, right? X squared. So when we solve this, we get 48 equals x squared, and then when we take the square root of both sides, we get that radical 48 equals x. And I'm not going to simplify here because that's not what this question is testing, so we can just leave it at FB equals radical 48. Now, last but not least, it wants the length of EC. Now, for the length of EC, that is this portion right over here. So we can go ahead and name that X. And what I see here is we have 2 chords that are intersecting. And when we have 2 chords that are intersecting, we use that formula where we do A times B equals C times D, right? So for A times B, we can take a look at this first chord right here. We can do 3 times 6 equals 9 times x. So we get 18 equals 9x, and we get that, when we divide by 9 on both sides, we get that 2 equals x, which means EC is equal to 2. Now, again, this question was very involved. There's a lot going on in here. There's not going to be, and we were asked 5 different things in this one question. That's not really going to be the case. You might be asked 1 or 2 of these things so that your picture doesn't get so messy. But the whole idea is annotate your question, figure out the segments that are present, figure out the theorems and formulas that you can use, and just take your time.